So this graph right here shows the car's displacement over time. So displacement is basically telling us how far the car is from its starting point and in what direction. So at the beginning, the car is close to the starting point right here. So the displacement is near zero, right? So right here, you see it's near zero right there. So as a graph rises right here, so let me go ahead and so as the graph rises, the car is moving farther away from where it started in the positive direction, right? So that's what's happening right here. At first, the graph gets steeper. That means the car is moving faster, right? So it's like really steep right here. It's moving faster. Near the top, the graph starts to flatten out. So, right, and then you can see it's flat right there. That means the car is starting to slow down. At the highest point, the car stops for a moment and then changes direction. After that, the graph goes downward. The car is now moving back towards its starting point, so its displacement is decreasing. When the graph reaches zero again, the car has returned to its starting position, so it's over here. Near the end, the graph goes down below zero. That means the car has passed its starting point and is now moving on the opposite direction. So the basic story is a car moves away from its starting point, slows down, stops, turns or reverses, comes back, and then passes where it started. So this graph right here shows the car's velocity over time. At the beginning, the car's velocity is close to zero. So you see that right here. So this means the car stopped or it's just starting to move. As time passes, the velocity increases. This means that the car is speeding up in the positive direction. It reaches a maximum velocity of about 5. So that happens about right here. And you can see that 5 right there. That is the maximum velocity that it reaches. After that, you see the velocity starts decreasing. The car is still moving in the positive direction, but it is definitely slowing down. That's what the graph is showing. When the graph reaches zero, which it's about to do right here, whoops. When the graph reaches zero, the car has stopped, right? So that's what's happening right there. Then the velocity becomes negative, and everything below that zero you see is negative right here. The velocity, it means that the car has changed direction, and that is what is happening here. So it's basically going in reverse, right? And now it's just moving in the opposite direction, and that's why it's in that negative. The velocity continues becoming more negative until it reaches about 3, and that means that the car is speeding up in the opposite direction. Finally, the graph levels off of around -3. Since the velocity is staying about the same, the car is now moving in the opposite direction at a very nearly constant speed. So the basic story is here is the car speeds up, slows down, stops, reverses direction, speeds up again in that direction, and then travels at a constant speed in the opposite direction. And that's what you see happening right here in this graph. All right, so this graph over here, and let me move this back right there. So this graph right here is showing the acceleration over time. So acceleration tells us how quickly the car's velocity is changing. So at the beginning, the acceleration is positive right here, and you can see it's just above zero. That means the car's velocity is becoming more positive, so the car is speeding up in that direction. So I'll just push play right here. You can see that happening right there. So the acceleration then decreases towards zero, and you can see that starting to happen about right over here in this area. When acceleration is close to zero, the car's velocity is not changing very much. Around 5 seconds, the acceleration becomes strongly negative. And so you see right here around the 5 second mark. This means the car's velocity is decreasing quickly. The car slowing down as it approaches a point where it will stop and change direction. After that, the acceleration stays negative for a while. This causes the velocity to become negative, meaning the car is now moving in the opposite direction. So that happens right here in the video. You see right there, it starts reversing. Later, the acceleration moves back towards zero. And you can see that happen right here. That means the car's velocity is becoming more constant. So near the end, the acceleration stays close to zero as the car is moving at about a constant velocity. So the basic idea here, and let me just go ahead and finish the video right there. So the basic idea is the positive acceleration increases the velocity. So the basic idea is positive acceleration increases the velocity. Negative acceleration decreases the velocity, and acceleration near zero means the velocity is staying about the same. And so here I kind of broke these down. So I helped you out here by breaking down, like, more or less the time intervals that you should be looking at. So here for the first one that it gives you, it's increasing speed in positive direction, right? So the next one, for the next time interval right here, you should be explaining, is it increasing speed in a positive direction? Is it decreasing speed in a positive direction? Is it at zero? Is it increasing in a negative direction? Is it decreasing in a negative direction? So if it's going, according to the video, remember, it's going forward, it is increasing speed in a positive direction. If it is at zero, that means it's stopped, right? And if it is going in the negative direction, then that means it's going backwards, right? So keep all those things in mind when you are doing this part right here. So here, use those same time intervals and then just basically say what it's doing when it comes to displacement. Remember, displacement is how far it's getting from the starting point. Velocity right here is how fast it's going and in what direction. Remember, positive acceleration is the velocity is becoming positive. Uh, Negative acceleration means a velocity is becoming negative. And zero acceleration means that velocity is about zero, right? So use those same time intervals right here, and then just describe what's happening with displacement, velocity, and acceleration.